factoring. That's going to be a key to what we're going to do with this section and with a lot of the stuff in, we're dealing with rational expressions and equations and functions and those things that we'll be doing on Tuesday. So factoring, we had a kind of a step-by-step process that we went through when we were factoring, and I call it the rules of factoring. So the first thing that you wanted to make sure of is that you had that thing in descending order. Biggest exponent first and go down. All right. So when we're factoring, we want descending order. And then the second thing we always looked for in all of our factoring was the greatest common factor. So we looked for that, something that every term had in common. And we called that the GCF. So we're looking for the GCF first. If there is one, pull it out and then go from there. If there's not one, then you're stuck to skip to the next step. If there is one, you're still going to the next step after you've pulled that GCF out. And the next step was to count the terms. And when you counted the terms, that told you what method you could use to factor out of that. And we had 3 different scenarios that could happen with things that we would see in a Math 100 or Math 110 situation. One of those things was that there were 4 terms. If there were 4 terms, we could use this method called grouping. We didn't get to use that straight out of the box a whole lot, but we did use it quite a bit when there were 3 terms, and we had to use that X method that I showed you. Okay, and we ended up making the problems have 4 terms, and then we used grouping. So we used that method quite a bit, the X method. So we're going to use that quite a bit tonight when we're doing this, and as we go through Tuesday's lessons, we're going to do X method quite a few times there. And then the other option was when there were 2 terms, and we saw a lot of differences of squares. I don't know what difference is, but it's difference of squares. And then we also had the sum or the difference of cubes. And we're just going to run through a quick example of some of these methods of factoring before we get into the rational expressions here, and then dive into doing some stuff with the rational expressions that involves factoring. So factor completely is going to be the instructions. So we're just, all our job is here is to factor this and go from there. So we're going to factor. Let's start with something fairly simple, maybe something like an x to the second power minus 7x plus 12. Something like that. Nothing too crazy, but definitely something we need to be able to factor. So it's a trinomial. It's got 3 terms. We look at all 3 and we say, okay, it's in descending order because we got x squared, then plain x, and then a number. So we got checkbox 1. We look for a GCF. 7 and 12 definitely don't have anything in common. So no GCF across the whole problem. But there are 3 terms, so that tells me that I'm going to use this X method. And to get that number that went on the top of the X, we always took the number that was in front. In this case, it's an understood 1 that's there. 1 times 12 is 12. And then this number that's in the middle always goes in the bottom. So it's a -7 in this case. So -7 goes in the bottom. And what we were looking for on the sides of our X was, okay, what number multiplies to be positive 12 and adds to be -7? Good job. -4 and -3. Those are the 2 numbers that multiply to be positive 12 and add to be -7. So because there's a 1 in front of x squared, that allowed us to do the shortcut to the factors. And that's always a helpful thing, especially now that we're going to take this factoring and do something else with it in the lesson that we're about to do. Okay, so that shortcut's always a helpful thing. The shortcut was, okay, if it's a -4 here, the factor is x minus 4. And if it's a -3 right there, the factor is x minus 3. If it were a positive number there, it just changes it to a plus. Okay? So that was the shortcut that we could use. And that only happens if there's a 1 in front of x squared. If there's a different number there, that's when we got to do the grouping stuff anyway. Okay. So there's an x method form of factoring. So there's that one. Let's look at maybe something like this. 4x squared minus 49. Good number. So it's in descending order because we got x squared and then we got a plain number. So, you know, that's in the right order. Look for a GCF 4 and 49. If that were a 48, yeah, that works good, but it's not. So there's nothing in common between us, so no GCF. So we look to see which method we should use. Well, there's only 2 terms, and the x has a squared on it. So that makes me think, okay, it's got to be, if it factors, it's going to be a difference of squares, okay? So the way we did that is we tried to rewrite it as what squared gets me 4x squared? Well, what squared gets me a 4? 2. And then an x gets me x squared, right? And then what squared gets me 49? Or maybe you want to think about it as square roots. What's the square root of 49? It's 7, right? So maybe that's an easier way to think about it than thinking what squared gets me that, and just think in terms of square roots. Because we could rewrite that way, that means it factors real easy. We get 2 factors, just like on example A. The front has 2x in it. The back has a 7. One's a plus, one's a minus. And there is a difference of squares. So we've got an x method there with a leading coefficient of 1, and there we have a difference of squares that we can do. So both of those methods are very useful in simplifying here. We're going to see those when we get into this rational expression stuff in just a second. All right, so let's look at another one that's maybe a little tougher. Maybe it requires the grouping stuff. Let's see. Let's take 4x squared. I'm trying to make this up off the top of my head here. Let's do a 10. So plus 13x. Let's do that. 4x squared plus 13x plus 10. All right. So descending order, check. It's already there. Most of them are already going to be in descending order. That's why I'm not making you have to rearrange here. When we get a rational expression, usually it's already in that order. And then GCF, 4 and 10 have 2 in common, but the 13 messes that up. So no GCF across the whole problem. So now that tells us, okay, we got what method do we use? There's 1, 2, 3 terms. That's an x method. So I'm going to set up my x. What goes on the top of that x? $40. You take that number that's in front, 4 times 10, and that's where the 40 comes from. Right? And then on the bottom of the x is always going to be that middle number. It's the only one we hadn't used yet, so that's what goes there. And so we need numbers that multiply to be 40. So I got to multiply to be that number up top and add to be the number in the bottom. 40's got a lot of options. It's a tougher one. 20 and 2, it doesn't work. That's 22. 4 and 10 is 14. That's close. What's another option? 5 times what is 40? 8. 5 times 8 would be 40. So 5 and 8 works. All right. So now, because there's a number in front of x squared, I can't do that shortcut on this one. It's got a different number other than a 1. So I've got to do the work of taking 4x squared and then replace the 13 with these 2 numbers from the sides. I'm going to put the 8x in the front because it makes sense to put 4 and 8 together, right? Because that's an easy GCF. And then that makes me put the 5x next, and that makes sense to put the 5x and the 10 together, right? It doesn't really matter which order you put that in, but it just seems to make sense to do it that way. All right. And then we group from there. So we're going to group the first two together and the last two together. And the first group, 4x squared and 8x, we get the GCF of those two, which would be 4 and x. And that'll leave us x plus 2 in the parentheses. Okay, so the GCF of 4x squared and 8x, 4 goes into both of them. Each of them have an x. So that's why it's 4x. And then what times 4x gives me 4x squared? That's x. What times 4x gives me 8x? That'd be a positive 2. Okay. Then the last group, you got 5x, positive 5x, and positive 10. So we know it's going to be a plus sign in the middle because we're always going to use that same symbol that's right there. So if it's a plus there, it's always going to be plus in the middle. If it's a minus in the middle, it's going to be a minus in the next step. 5 and 10 have a GCF of 5. So, and then what times 5 gives me 5x? X. What times 5 gives me 10? 2. No surprise that those parentheses here match up. If they don't match, something's wrong. Okay. And then that means our final factors for this would be 4x plus 5 and x plus 2. 4x plus 5 and x plus 2. So there's a little bit of a review on factoring on the videos for the labs. There's another review. It's got different problems on that. So that'll help you kind of get back going on factoring. We did that in 100. It's going to be used again quite a bit in 110 here. So there's a lab that's specifically for reviewing factoring and got you some practice problems with that. And there's a review video that goes with it. So got you a little extra review in there with that. So let's get into the rational expressions. And what in the world is a rational expression? A rational expression, it's just a fraction. That's all it is. A rational expression, the first 5 letters of rational are ratio, and ratios are normally written as fractions. Okay, rational expression is just a fraction. Our fractions that we're going to be dealing with happen to have fraction. It'll be polynomials in the top and bottom. That's what we're going to be dealing with. Rational expressions, technically, it's just a fraction in general, but we're going to be dealing with ones that have polynomials on top and bottom. So we're going to have to deal with those. So one of the things that we're going to do as we go along here is talk about the domain of a rational expression. And when we talked about domain before, we're talking about the x values. And a rational expression, if it's a fraction, that was one of our red flags. And when we talked about domains with functions, was if there was an x in the denominator, we had to deal with that. So that's what we're going to be dealing with here, is with the domain of a rational expression. We want to find that. So here's a very important statement, that the domain of a rational expression should be found, capital letters, before simplifying. Okay? Before you simplify, you got to find that domain. Okay? We're going to simplify some fractions, polynomial fractions in that case. But the domain, if it asks for the domain, you got to find it before you simplify. Because if you don't, you'll lose a few pieces possibly out of that. So if you don't find the domain before you simplify, you're going to lose a little bit of some of your answers possibly. And with a multiple choice type situation, they're going to have one of the answers is going to have the ones that are supposed to be there, and then one of the other answers is going to have the ones if you forgot some, or if you simplified first. So that's going to be the case. So when we're looking at this, we're going to be simplifying fractions. So let's start with simplifying a regular number fraction. and then jump into simplifying polynomials. Okay, so let's talk about what does it even mean to simplify a fraction. So when we were, it's not example A, it's example D, I believe. Yeah. All right. So when we were simplifying fractions back in elementary school, and they were talking to us about simplifying fractions, they'd give us a problem that might be something like maybe it was 28 over 35, something like that. And they said, simplify that fraction. And they tried to teach us ways to do that. And then as we got older, they gave us a calculator, and we realized the calculator can do it. We kind of forgot how to do that a lot of times. Now, what's happening here when we're simplifying that is you're trying to look for things that go evenly into both of those, right? So what's the biggest number that goes into 28 that also goes into 35? That's what they told us to look for. But what we really were doing is we were canceling out a common factor of those two. And if we think about the factor tree for 28, so if we did 28 and we did the factor tree for that, that'd be 2 times 14 and 2 times 7. So 28 is actually 2 times 2 times 7, right? That's the same thing. If we multiply it out, 2 times 2 times 7 is 28. 35, if I do the same thing for it, it's a little easier because it's just 5 times 7, and it doesn't break down any further. And then that makes finding the common factor pretty easy, right? That common factor is 7. Whether I really knew 7 went into both of those or not, my factor tree found it. And I cancel out the common factor. So these two were the common factor, and they cancel each other out. And I end up with 2 times 2 over 5. Or, you know, when we did this in elementary school, we got 4 over 5. And we would normally do that by just dividing 28 by 7 and divide 35 by 7. But when those numbers got really, really big, and they had like a 4-digit number on the top and a 6-digit number on the bottom, then, you know, it got tougher to do. With a polynomial, it looks really hard to do because we got all these x's and things in there. But the key is just factors. Just like on this, where we found common factor and canceled it out, we found that, hey, it happened to have the same factor on top and bottom. That's what we're looking for when we're simplifying rational expressions, okay? So when we simplify, we're going to factor it as far as we can, and then to look for the matching ones. If they match, they're gone, okay? So that's what we're going to be doing. We're just going to do it with polynomials instead of numbers. Okay, so it's the same idea as we did with numbers, but it's polynomials. The factoring's tougher because it's polynomials, obviously. But now, domain, we're going to do the way we did it in 100 with the red flag stuff. So let's do that. So the instructions are going to be find the domain and simplify. All right. So start with one that's already in the factored form. Okay. X minus 7, parentheses, and then another set of parentheses, x minus 1. That's the top half of the fraction. That's the numerator. X minus 7 times x minus 1. The denominator, let's do x minus 1 times x plus 3. Okay. So it's already factored for us. They're not going to give them many of them. We're going to have to factor them ourselves most of the time. But this kind of gets the idea rolling, all right? So when it tells me to find the domain and simplify, and it may not even say it in that order. It may say simplify, also state the domain. It may say it in a different order. We've got to keep in mind that big statement that I wrote up here, that you got to find that domain before you simplify, okay? Because I think we can all look at the example E and see which factor is going to cancel out. Hey, it's that matching one. We know that's going to happen, but if we cancel it out before we do the domain, we're going to lose part of our domain out of that, okay? So the red flag idea that we had in 100 was that if there was an x in the denominator, you had to do what in order to find the domain? Find the domain when there was this red flag going on that there were x's in the denominator. we had to set the denominator equal to 0. So we set the whole denominator, in this case, equal to 0. And it's already in factored form, so we're kind of ahead of the game here. Because we're setting it equal to 0 and it's already factored, we're going to take each individual factor, x minus 1, set it equal to 0. X plus 3, set it equal to 0. And then solve each of those separately. So plus 1, so x is equal to 1, and then subtract 3, x is equal to negative 3. So the domain for this problem is going to be all x's such that x does not equal negative 3 or positive 1. That's the set notation for it. Okay, so there's the set notation for the domain. The interval notation for that is parenthesis negative infinity to negative 3 parenthesis u for union. Then we're going from negative 3 up to positive 1 parenthesis u for union. And then we're going from 1 to positive infinity. So what that's doing is it's cutting out the negative 3, jumping over that number, and then jumping over the 1 that is also one of the places that could make the denominator equal to 0. Okay, what that does, the domain, that tells us what x's we can use and which ones we can't use. Okay, the set notation is more focused on the things you can't use. The interval notation tells you what you can use and what you can't use both. So that's why the interval notation is such a big deal in higher level math, because you get more information from it. So that's why we're using that. So this is our domain. Be able to do both ways of writing that in set notation and interval notation. Once you've found the domain, and when you're finding the domain, you're going to just set the denominator equal to 0. You want to use factoring to solve it. This one was already factored for us, so we didn't have to do that. We just used the factors to get the answers. Once you found the domain, you go back to the original problem, and then you start simplifying and canceling out things that match. Because on this original problem, you got these two factors that match, one on top and one on the bottom. I can cancel them out. X minus 7 doesn't match the x plus 3, so it's left over. This is the simplified version of that original problem. Okay, so factoring, we're going to have to do the factoring on the next several problems. This one was already factored for us just to get the idea of what's happening out of that. All right, so it's going to take factoring and then finding the domain and then simplifying. Okay, so let's look at one where we've got to do it all. We've got to do the factoring, we've got to find the domain, and we've got to simplify. So same instructions, find the domain and simplify. So here's our problem. X squared minus 6x plus 5 over x squared minus 25. Okay. One thing I will caution you on, and this is a common mistake with this material, is you cannot cancel the x squared and the x squared together. You can't cancel things that are tied together with addition or subtraction. You can only cancel factors, things that are multiplied together. Like up on here on the example E, x minus or x plus 1 there, or excuse me, x minus 1, it was multiplied times the x minus 7, and this x minus 1 was multiplied times the x plus 3. So that made it legal, and they matched perfectly. On this problem, you've got an x squared, and it's subtracting 6x and then a plus 5. So it's got it's a whole different thing, okay? So you can only simplify and cancel out things that are part of factors. So you got to do factoring first, okay? So let's start out by finding that domain. That's always, if it asks you to find the domain, that's going to be your first step. We won't find the domain on every problem we do tonight. With this, we're just getting the idea of the domain. When we go to next on Tuesday, we'll be doing some function stuff, and we'll have to find the domain then. I just want to introduce it today to get you started with it. All right, so the domain, the rules are, if it's a fraction, look at the bottom part and set it equal to 0. So we're setting x squared minus 25 equal to 0. I know that there are other ways to solve that besides factoring. I could move the 25 and then take square roots. But because I know I'm simplifying a rational expression, I want to use factoring because it's going to help me do the simplifying. Okay. I know that it's a quadratic and I could use quadratic formula to solve it. That doesn't help me simplify it though. So when you're trying to find the domain, you want to use factoring to help you because it's going to help you with the next step. So that's why, we're going to factor this and not use another method for solving that problem, even though square roots would be the fastest way to solve it. But factoring is going to help us speed up the next step. Okay, so that's got two terms and a minus sign in the middle. So that looks like a difference of squares to me. X and 5, right? 5 squared is 25. So my factors would be x plus 5, x minus 5, right? And then I take each of those factors and set them equal to 0. All right, so that's what I'm going to do. X plus 5 equals 0. X minus 5 equals 0. And I know you probably can take some shortcuts on that, and I'm fine with that. Negative 5 and positive 5. So my domain will be all x's as long as x does not equal negative 5 or positive 5. And then the interval notation's a lot longer to write, but it's got more information in it. So start with the one that's negative, or the lowest one, negative infinity up to that number, parenthesis u, parenthesis 5, negative 5, up to the next number, 5, parentheses 5 to infinity. So there's our domain. And set notation and interval notation for that. If you wrote it like this, that's on the set notation. I would take that too. You don't have to write out negative 5, comma 5. If you wrote plus or minus 5 in there, it's the same thing. Okay. I'm not sure which way it is on the Canvas quiz. That's why I bring that up, because I can't remember which way it is. All right, now let's take that, and we're going to use that factoring that we did. Because we've already factored this, we're going to use that as a shortcut on our simplifying. That we've already got x plus 5, x minus 5 on the bottom. We've already done that part. That means all we've got to do is factor the numerator to help us here. Okay? So that numerator, when I go to factor it, I look at all the rules. Rules of factoring are descending order. It's already there. I look for a GCF across the whole problem. There's not one. And then I say, okay, there's 1, 2, 3 terms. So that tells me to use the X method for factoring that. 1 times 5 is 5. Got to add to be negative 6. Negative 1 and positive 6. Can I use the shortcut to factor that? Yes, because there's a 1 in front of x squared. So that means my factors are x minus 1 and x. Well, it's not 1 and 6. Back up. 1 times, it'd be 1 times negative 1 times negative 5, wouldn't it? Guess we got to multiply to be the top number and add to be the bottom number. I'm sorry, I got in a hurry too. I got in a hurry too, so it's okay. So we got a negative 1 and a negative 5 that multiplies to be positive 5. Negative 1 plus negative 5 adds to be negative 6. So that means our factor is x minus 1 and x minus 5. And now, hey, we got a couple of them that match here, and we're going to cancel those out. And that gives us a simplified version of x minus 1 over x plus 5. So we're factoring and trying to simplify. So domain is factoring, but set the denominator equal to 0. So anytime you got to find the domain, it's the denominator set equal to 0. Use factoring to get you there, because that's going to give you a shortcut on the, or kind of a heads up on the simplifying part. Okay, always try to use factoring if possible. There's times where you can't factor, but it's not very often in this course anyway. All right, let's look at some, and we'll just take the domain part off and just simplify. We'll focus on the simplifying part, because that's the main focus of this section, is the simplifying part of the material. So what are we on F? G. All right, so instructions are just simplify. We're not going to worry about domain on the rest of the problems that we're going to do today. So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 more examples. If you can hang with me for 10 examples, we'll get out of here. All right. So example G, 12x squared minus 30x over 4x squared minus 25. So again, we're going to simplify this. We're not worried about the domain, so we'll just start factoring at the top, okay? So if I'm going to factor that numerator, it's in descending order. Is there a GCF? 12x squared and 30x. 12 and 30, what goes into those? I think there's something that goes into both of those. Which one do we want to use? 6, because it's the biggest, right? So 6, and then what else do both of them have in common? Both have an x, right? This one's got x squared, and that one's got plain x, so it's just going to be 1x that comes out. So 6x is the GCF of the top. What's that leave in the parentheses on top? What times 6x would get me 12x squared? 2x, good. What times 6x would give me a negative 30x? Negative 5. Okay. So we've factored the top part, because what's left in the parentheses doesn't fit any of our rules. It's not a difference of squares. It's got 2 terms, but it doesn't have a squared on the variable anymore. So now we've factored the top part completely. Let's factor the denominator, the bottom part of the fraction. So it's got 4 and 25. Is there a GCF between those two? No. Okay, so then we start looking at the other rules. It's got 2 terms with a minus sign in the middle and an x squared. So that makes me think difference of squares. So I'm going to try to rewrite it as a difference of squares. We know that 2x would get me 4x squared. We know that 5 would get me 25, right? So the factors for that would be 2x minus 5 and 2x plus 5. And it doesn't matter what order you put those in, as far as the plus one or the minus one first or second. And we have now factored the denominator as far as it'll go. And then we look for common factors. What factor matches? 2x minus 5 cancels a 2x minus 5. And then that leaves us 6x on the top and 2x plus 5 on the bottom. And again, you cannot simplify the 6x and the 2x, because the 2x is tied to the plus 5. Okay, if that were just 6x over 2x, yeah, you could simplify. But because it's got a plus 5 tied to the 2x, you can't do one part. You've got to do either the whole factor or none of it. Okay. So there's the simplified version of example G. So again, factoring is going to be your key to simplifying. Let's do this one. X squared minus 8x plus 16 over negative 2x squared plus 8x. So doesn't matter whether you start on the top or the bottom. I don't care either way. I'm just going to start on the top because it's the first one I see. All right. GCF, is there one for that one, for the top part? Well, 8 and 16 have something in common, but this one in the front here doesn't help us. So I'm going to use the X method. Multiply to be 16 and add to be negative 8. If it's going to add to be negative, I know both of them are going to be negatives because it multiplies to be a positive. Negative 8 and negative 2 would get me negative 10 when I add them together, so that can't be it. Four and 4, 16. 4 times 4 is 16. So negative 4 times negative 4 is still 16, and that's the right number. So that means I can take the shortcut here on my factoring because I got a 1 in front of x squared. I get x minus 4 and x minus 4. There's two of them there. Just handy. The denominator, it's a little weird because it's got a negative on the first term and then a plus 8x. So when I look at that, is there a GCF across those two? Well, they both share an x, so I know that's in there. But 2 and 8 are both divisible by 2, right? So I know 2 is going to come out. Here's the trick to one like this. If there's a negative in the front of the leading term, when you pull that GCF out, pull a negative. So I'm going to pull a negative 2x out. The reason I'm going to do that is because I want that what's left in the parentheses to match one of those guys up there. So what times negative 2x gets me negative 2x squared? Just an x, right? And what times negative 2x gets me a positive 8x, a negative 4. And now I've got two that, these things are going to match up. And that's the trick. Anytime there's a negative in front of the leading term, you want to pull that out with your GCF. That will save you a lot of headaches over the course of the rational expressions if you do that. So those cancel out. And then I got x minus 4 on the top, negative 2x on the bottom. And there's our simplified version of that. Again, if it asks for the domain, you would set this denominator right here equal to 0. So you get 0 and 4 as the numbers that could not be in the domain for that. All right. Not bad. Okay. It's not terrible. It does require you to be able to factor, though. Yeah, that's the key. All right, so let's look at this one. Let's say we had 5x squared plus 20x over 2x squared plus 7x minus 4. So numerator, start with it. It's fine. It's a GCF of 5x squared and 20x. 5, and what else do they share? an x. What's left in the parentheses then? Good job. X plus 4. Bottom part, 2 and 4 have something in common, but the 7 messes that up, so there's no GCF. So I'm going to do an X method. -8 on the top, 7 on the bottom. Multiply to be -8 and add to be +7. Thinking 8 and -1. That multiplies to be -8. 8 plus -1 is +7. I can't use the shortcut here because I got a 2 in the front, so I've got to do the long version of this, the grouping, 2x squared. I'm going to put plus 8x minus 1x minus 4. Group. So 2x squared and 8x. They got 2x in common. Give me x plus 4. And then this is the one that kind of can sometimes confuse us a little bit. -1x and -4 have -1 in common. 1 goes into both of them. There's nothing else that does. And that leaves you the x plus 4. So our factors would be the x plus 4 and the 2x minus 1. Which works out really nice because now the x plus 4s, 1 on top, 1 on the bottom, cancel each other out. And there's 5x over 2x minus 1. So single fraction, factor, top and bottom, cancel things that match up on the top and bottom. But you got to factor first. Okay? If you don't factor, it doesn't work that way. You have to factor. All right. Now, let's talk about multiplying two fractions together. So we're going to, again, go back to the old school, just a regular fraction with numbers in it, and talk about how we did this in elementary school, or one of the methods for doing that. So when we're multiplying fractions, let's take, for example, 6 over 7 times 21 over 30. There were several ways that they taught us how to do this in elementary school. One of the ways was to just multiply straight across and say 6 times 21 and 7 times 30, and then simplify from there. And that worked, but it made us have to do really big numbers and start breaking those down. So they taught us this other way that was called cross-canceling. You may remember that word. It may bring up bad memories for you, chills down your spine kind of thing. But it was cross-canceling, and that meant you looked at the diagonally. You looked at it and said 6 and 30 have what in common, and you tried to cancel out from there. And 7 and 21 had what in common, you tried to cancel out from there. Really what we were doing is the same thing that we've talked about here, is we were trying to cancel out common factors. So if we think about the factorization of 6, 6 is 3 times 2, right? So this is really 3 times 2. And then 7 was a prime number, so it's just 7. Nothing going on there. And we think about the factorization of 21. It's 7 and 3. So that's 3 times 7. And then 30, it was a little tougher because, you could do 3 times 10 and then 2 times 5. So you had 2 times 3 times 5. So you had all of those factors that were happening there. And there were 2 different ways you could cancel. One was diagonally, and the other one was vertically. Okay? And so if I look at this first fraction, there's nothing that cancels vertically. But on the second fraction, I got a 3 up top and a 3 in the bottom. So those 2 could cancel each other out. So I'm looking vertically first, And then I started looking diagonally and said, okay, 7 and 7. I got a 7 on the bottom and a 7 up top, and those two canceled each other out. And then diagonally, I had a 2 up top and a 2 on the bottom, and they canceled each other out. And the only thing I had left was a 3 and a 5. So that meant my answer was 3/5. Now, when we did this in elementary school, we probably said, okay, 6 goes into itself once and into 35 times. 7 goes into itself once and into 21 3 times. And then we multiplied 1 times 3, got 3/5. 1 times 5 and got 5. And that's how we ended up with 3/5. That's what we did. All this stuff I just did right here is what was really happening. That's the math that was going on that we were kind of taking advantage of. Now, when we try to relate this to functions and polynomials, the way that's circled there is what we got to think about. We got to think about factoring everybody and then canceling vertically and diagonally. We never can cancel side to side. We can only cancel vertically or diagonally. No other ways, okay? So when we look at a polynomial or a rational expression, multiplying those together that has some letters in it. Let's start with one like this. And it's just, again, simplify. It might say find the product. Same thing. Either way, you got to simplify at the end, all right, or as you go. So let's take one like this. 6x to the 6th over 7 times 28 9x squared. Okay. So here we throw some letters in there. We're going to throw some bigger polynomial stuff in there in just a little bit, but let's start with something easy like this that's a little bit more doable. Okay. So let's think about it in the way that we did back in the previous problem. We know that 6 is really 3 times 2, and then x to the 6th was x, 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 x. And then 7 is just 7. It's pretty boring, right? So that's 6 x's that I've written there, and then a 2 and a 3. And then this fraction, the 28, if we did the factor tree for 28, that's 4 and 7, 2 and 2. So that's 2 times 7. And then on the bottom, 9 is 3 times 3, and then x squared is x, x. So I'm just writing it out in the factorization of that is what I'm writing out. Okay. You don't have to do it this way. I just think it makes it make sense at the beginning. Okay. You can start doing shortcuts and things. If you can do the shortcuts already, that's fine with me. I'm just saying this makes it, I think, makes sense. All right. So we're going to start canceling things vertically or diagonally. That's the only way that we can cancel things. So vertically, this first fraction, the 3 doesn't cancel the 7, the 2 doesn't cancel the 7. There are no x's on top and bottom, so I can't do anything to that first one. The second one, this 2 doesn't cancel anything. The 7 doesn't work vertically. So nothing can happen vertically, but there's quite a bit that can happen diagonally because I've got a 7 that'll cancel a 7. I got a 3 that'll cancel a 3. And then I've got an x here that'll cancel one of those x's. I got another x that'll cancel another one of those x's. So now I've got a 2, a 2, and a 2. So 2 times 2 times 2 would be 8. And then I've got 1, 2, 3, 4 x's. So that's x to the 4th power. And then on the bottom, all I've got is a 3. So I end up with 8x to the 4th power over 3 in the bottom. So I think that makes it make more sense. It's because you're canceling out individual factors. Now, there are shortcuts, obviously. 6 and 9 are both divisible by 3, and you could change that to a 3, or to a 2, and this to a 3. 7 becomes a 1. 28 becomes a 4, right? And then 2 times 4 is 8. And then here, the x squared and the x to the 6, 2 on the bottom, cancel 2 at the top. So there's why there's 4 left. But this, you get to really visualize what's happening. Why are they getting 4 x's? That didn't make sense to me. Well, it's because there's 6 of them up top, 2 of them on the bottom, 2 cancel 2. And then you got 4 left. So again, you can take the shortcuts out of that. As long as you're getting the right answers, I'm good with that. But I like to write it out like that for the first few examples, just show you exactly what's going on, that it doesn't take a lot of extra work to do it the long way and visualize what's happening. Let's look at one that's it's polynomials involved, not just expressions with letters. It's got letters, but it's a polynomial. Say we had x plus 4 in parentheses, x minus 3 in parentheses on the top, and then an x minus 3 and an x plus 3 on the bottom. Okay. Times another fraction that has an x plus 5 on the top, and then an x plus 4 on the bottom, and an x minus 1 on the bottom. It's already factored for us. We don't have to do any factoring on this one. So this one is kind of like at this step of that problem. So it's everything's already factored for us. We're just looking for matching stuff, okay? And when we're looking for matching stuff, we can go vertically or we can go diagonally. Never side to side, always vertically or diagonally to cancel. So we look at find the factors that match vertically or diagonally. So we got an x minus 3. We got an x plus 4 up here and 1 down there. They cancel each other out. Then I'm looking for something else, but there's not anything else that's going to cancel out. So the top part has the x plus 5. The bottom part has both of those. It has x plus 3 and x plus 1. And just leave it in that factored form like that. It's absolutely fine. You don't have to multiply it out. So already factored form, it's pretty easy to do. You're just kind of canceling stuff out. Okay, so if it's in factored form, cancel out the matching factors. Well, guess what? Most of them aren't. You got to do the factoring yourself, okay? So let's look at one that we got to do the work on, okay? So let's say we got 4x squared plus 3x minus 10 over 2x squared plus 3x minus 2 times 4x squared minus 1 over x plus 4. We'll do an easier one on the bottom there. We don't have to do anything to it. Okay, so this one has quite a bit of stuff going on. We got, looks like 3 of the 4 things have to be factored. Okay, and that's not uncommon for all 4 of them to have to be factored. All right, so we're going to look at this and we're going to try to simplify as much as we can on this. So we got to do a lot of factoring out of that. All right, so let's just start with the top left and factor that trinomial there. So that tells me it's a trinomial. I got to do an x method. So that'd be negative 40, add to be 3. 8, negative 5. And since it's got the 4 in the front, that means I can't take a shortcut. So I'm going to have to write it out. And then group it. 4x, x plus 2. That's got a minus 5. And then x plus 2. So the top left, that fraction is now 4x minus 5 and x plus 2. I'm done with that. Okay. So that right there is the factoring for that. So I've got, this is kind of like scratch, my scratch word. where I'm factoring those. Okay. Let's do the bottom part of that fraction since it's right there with it. So just might as well factor it too. So it's an X method as well. So I'm going to do X method. And 2 times negative 2 is negative 4. And add to be 3. That'd be 4 and negative 1. Right? And I can't do the shortcut on that one again. Group. First pair, 2x squared and 4x have 2x in common. These x plus 2. And these, they don't have much in common, but they got a 1. And because this is a minus sign right there, it's going to be a negative 1. And then that changes it to x plus 2. So the factoring on the bottom here is going to be x plus 2 and 2x minus 1. And a lot of times folks want to go ahead and just cancel that. I'm going to wait and do all that at the end after I've factored everything. We see that that's going to cancel, though. That's the nice part about it. You already see that happening. So the next fraction gets a little easier because there's only one of them to factor, and it's a difference of squares. 2x and 1. So that means the factors are 2x plus 1, 2x minus 1, which is nice because I see a 2x minus 1 diagonal from that. That's always encouraging. And x plus 4. X plus 4 doesn't factor at all. There's not a GCF. There's nothing, no method to doing that. That's it's just x plus 4. Okay. Now we start canceling things vertically and diagonally. That's the only ways that we can. So let's see. Blue's a good color. X plus 2 cancels x plus 2. 2x minus 1 cancels 2x minus 1. And then I'm left, final answer here is the factors that didn't get canceled. So I got 4x minus 5, 2x plus 1, and then on the bottom I've got that x plus 4. You don't have to multiply that out. You just leave it in the factored form there. It's fine. And just like that. So kind of a lot of work involved with this. It's not a short, none of these are going to be short problems, or relatively speaking, but very, very factoring heavy section here. So the practicing factoring is going to be important here. Let's do one that's got a cube thing in it, just to review that, because we haven't done that a whole lot. So let's do a cubed one, and then we'll do a division problem, and we'll be out of here. All right, so let's do x squared minus 1 over x cubed minus 1 times, let's throw an extra letter in there. Not x plus y, but xy plus 3x plus y plus 3. All right, so the second fraction's got, it's one of those where we get to actually use grouping from the get-go. We don't have to do anything extra to get there. So it's a little, it's actually, it looks long, but it's actually a quicker factor than some of the others. All right, so we're just going to factor everything that we can and go from there. So I know that the top one here, that's a difference of squares, x and 1. So I know it's going to be x plus 1, x minus 1. I see that difference of squares. I've done a ton of them, so it's really easy to recognize. So that's where a lot of practice factoring is important. So make sure you do the lab number 1 when I assign it this week. Do that before you do anything with this section R5, I think is what this is called. Yeah, R5. Make sure you do lab 1 before you do R5. If you don't, you're putting yourself behind the 8 ball there. All right, now the bottom part of the fraction is a difference of cubes. And if you remember from 100, we did sums and difference of cubes. Sums of cubes, a cubed plus b cubed, and differences of cubes. This was the pattern that we tried to memorize to be able to do those. So on this one, our a is x and our b is 1, because 1 is 1 cubed. Right? It's the same thing. Okay. So on the bottom part, our short factor is going to be off of this pattern. Okay. So x minus 1 is the short factor. The longer factor is going to be x squared plus 1x plus 1 squared is 1. That's the factoring of that difference of cubes. Those, again, if you hadn't done a lot of those, they're tougher to do because it's just memorizing that pattern and knowing it. And there's no substitute for practice. That's just the way it is. It's math. Oh, sorry. All right. Now, the other fraction is a whole bunch of grouping. Okay, so we're just going to group and go from there. So I'm going to group the first two, second two. First pair on the top, xy minus 2y. What's in common between those two? Well, they both got a y, right? And that's going to be x minus 2 left over. And then 3 and 6 have 3 in common. And that leaves us x minus 2. And notice the parentheses match. So that means that factors as x minus 2 and y plus 3. That's handy. I don't know if it'll help us any, but maybe it will. And then let's group the second one. The bottom part there. What do both of those have? In the parentheses. X, y, and 3x. They both got an x. Gives you y plus 3. And on the bottom, both of those have a 1. So that's y plus 3 again. So the denominator there is going to be y plus 3 and x plus 1. Once I've got everybody factored, I then can take that and simplify, start canceling out vertically and diagonally. We get quite a bit of stuff canceling on this one. So I got an x minus 1, different color, x minus 1 and x minus 1. Got a y plus 3 and a y plus 3. So those are the vertical ones that I did. It doesn't matter. I always do vertical first out of habit. It technically doesn't matter which way you do. If you do diagonally first, that's fine. It doesn't matter. Just see the ones that are the same and cancel. And the x plus 1s cancel each other out. And that leaves us just a simple old x minus 2 over x squared plus x plus 1. And there's our simplified version of that. So factoring, big part of this. It doesn't necessarily make it easy, but it's, your first step should be factor everything. That's when it's simplifying rationals, factor everything. All right, so let's look at division real quick, and then we'll be out of here. Okay, so just one example, because do we remember from elementary school when we did division of fractions? Let's say we had 2/3 divided by 15 over 4. How did we do? What was the rule for dividing fractions before we did it with a calculator? Change what? Change which one? We change it to a multiplication problem and we multiply by the reciprocal. You flip the second one. That was the rule for dividing fractions. So anytime you're dividing fractions, change it to a multiplication problem and flip the second one. Always going to flip the second one. And then do the math, do the simplifying if possible. This one actually doesn't simplify at all. We end up with 2 times 4 over 3 times 15. Should be 8 over 45. And it doesn't simplify at all out of that. Just because I made it up off the top of my head to do a number problem. Okay? So flip the second one and multiply. So that means when we do a polynomial question, and we've got something like x squared plus 7x plus 10 over 16x squared minus 25 divided by maybe 4x plus 5 over, put the 4x plus 5 on the bottom. 4x plus 5 on the bottom. And on the top, let's do x squared minus 4. All we've got to do is change this problem to a multiplication problem, and all of the rules are exactly the same. Okay, so we just rewrite the problem: x squared plus 7x plus 10 over 16x squared minus 25 times 4x plus 5 over x squared minus 4. And then we do the exact same thing that we've been doing. We factor everybody, cancel vertically and diagonally. So this one's a little easier factor. Thought I'd end up with a pretty decent one. I can do X method on the top one. 10 and 7 be 5 and 2. That's going to be X plus 5, X plus 2. On the bottom, 16X squared and 25. That's a difference of squares. 4X and 5. So that's 4X plus 5. 4x minus 5. The 4x plus 5 doesn't factor at all, so that's nice. And then the x squared minus 4 is a difference of squares because that's 2 squared and that's x squared. So it'll be x plus 2, x minus 2. And then once you get everything factored, it's cancel out vertically and diagonally. So don't see any verticals, but I do see some diagonals there. I got an x plus 2 and x plus 2. 4x plus 5, 4x plus 5. And that just leaves you on the top, we got x plus 5. On the bottom, we got the 4x minus 5 and the x minus 2. And that's it. So the division problems are just multiplication problems with one extra step. Flip the second one. Always flip the second one. First one stays the same. Always flip the second one. Okay? So factoring is the name of the game. Make sure when you're doing practice for this, do lab 1 before you do R5 because it's a review of factoring because you're going to be factoring a lot with R5. So make sure you're doing that. Some problems that you can look at with R5 in that section, just 1 through 77, the odd ones out of that in the textbook would be good practice for that. Get you a lot more practice factoring and all that stuff. So I'll send out an announcement again with the quizzes and the labs to do for tonight with the links to the videos that I've made tonight. And then